What's happening on Saturn right now is wild. The planet has been stripping off its clothes and showing us all the colors beneath. But why? Why does it do this? And what can we learn from these seasonal shifts? We'll have to dive deep into the gas giant's layers of mystery to find out. This is our channel. Join us as we explore the strange shifts in Saturn's atmosphere. Saturn is a fascinating planet with many unique features that set it apart from the other gas giants in the solar system. One of the most striking things about Saturn is the dramatic changes in its atmosphere as it makes its 29-year orbit around the Sun. These changes are so extreme that they even have their own names. In the northern hemisphere, summer lasts for 7 years, winter lasts for 7.5 years, and spring and fall each last for about 4 years. These seasons are not caused by the usual factors such as the tilt of a planet's axis. Instead, they're driven by something else entirely, which we'll get to later in the video. As Saturn moves through its orbit, different parts of its atmosphere are exposed to varying amounts of sunlight, which causes the gases to expand and contract, creating massive clouds that stretch for thousands of kilometers. During the summer solstice, which occurs every 14 Earth years, the North Pole is pointed directly at the Sun and the Northern Hemisphere experiences 6 months of daylight. This results in an expansion of hydrogen sulfide clouds in the Northern Hemisphere. Hydrogen sulfide is a colorless gas that gives off a rotten egg smell. It's also toxic and corrosive, which makes it pretty unpleasant to be around. However, when exposed to sunlight, hydrogen sulfide can react with other compounds in Saturn's atmosphere to form complex organic molecules. These molecules absorb red light and reflect blue and green, giving the northern hemisphere a greenish hue during summer. Meanwhile, the southern hemisphere, which is experiencing winter, remains relatively dark as it's shrouded in darkness for 6 months. But don't worry, it's not all bad news. Saturn's rings also put on a spectacular show during the summer solstice. As the sunlight hits the rings at a shallow angle, they become more visible and we get a chance to see their intricate details. Unfortunately, though, there aren't any pictures of this particular solstice, as the last spacecraft to observe Saturn up close was the Cassini probe, which stopped sending data back to Earth in 2017, but scientists use computer models and data from previous observations to make predictions about what's happening on Saturn. So while we can't see it for ourselves, we have some pretty good guesses based on what we know about the planet's atmosphere and its orbit. But don't worry, we won't have to wait much longer to see what's in store for Saturn's next solstice. NASA's upcoming Dragonfly mission will launch in the mid-2020s and arrive at the planet in the 2030s. It'll spend 2 years exploring Titan, Saturn's largest moon, before venturing further out into the Saturnian system to study the planet's atmosphere and rings. Dragonfly is expected to provide stunning views of the planet and help us better understand its fascinating features. So keep an eye out for updates on this exciting mission. You definitely don't want to miss it. The colors of Saturn's atmosphere change dramatically as it orbits the Sun. During the summer solstice, the northern hemisphere turns green due to the formation of organic molecules created when hydrogen sulfide reacts with sunlight. But as the planet continues its journey around the Sun, the exposure to sunlight changes, causing the colors to shift. By the time autumn arrives, the northern hemisphere starts to look like a burnt orange marmalade. Scientists think this color change might be caused by the breakdown of those same organic molecules that turned the planet green in the summer, but that's not all. Saturn's atmosphere is also full of other gases such as methane and ammonia, which can also absorb and reflect light at different wavelengths. The changing seasons cause these gases to interact with sunlight in different ways, creating the vibrant colors we see. For example, methane absorbs red and infrared light, while ammonia reflects blue and green. As the seasons change, the amount of each gas in the atmosphere changes as well, leading to different colors dominating the landscape. But it's not just the surface of Saturn that's changing colors. Its rings are also getting in on the action. As the planet moves through its orbit, the rings reflect the changing colors of the atmosphere, creating a breathtaking display of color and light. In fact, Saturn's rings are so complex that they have their own set of names for different features such as spokes, which are gaps in the rings that appear and disappear over time. The ever-changing colors of Saturn's atmosphere and rings make it one of the most beautiful planets in the solar system and a truly mesmerizing sight to behold. Now let's talk about what's going on below the clouds. Saturn's atmosphere is divided into different layers based on temperature and chemical composition. The lowest layer is the troposphere, where the temperature decreases with altitude. Above the troposphere is the stratosphere, where the temperature increases with altitude. The boundary between these two layers is called the tropopause, and it's a region of strong winds and storms. When the northern hemisphere of Saturn moves into summer, the temperature in the troposphere rises, causing the atmosphere to expand and form massive clouds. These clouds are made of hydrogen sulfide and reflect the greenish color of the atmosphere. As Saturn continues its orbit around the Sun, the temperature changes, causing the clouds to change color and fade away. But wait, there's more! Beneath the shifting clouds lies a churning sea of liquid hydrocarbons. Yes, you heard that right. Beneath the clouds of Saturn's atmosphere, there's a vast ocean of hydrocarbons such as methane and ethane. These liquids are in a constant state of motion, churning and mixing beneath the surface. Scientists believe that the movement of these liquids is driven by convection currents, similar to how water boils in a pot on a stove. The heat from the core of Saturn creates convection currents in the liquid hydrocarbons, causing them to circulate and mix. This churning motion is thought to be responsible for the dynamic range of colors we see on Saturn's surface. Here's how it works. As the liquid hydrocarbons move and mix, they interact with the gases in the atmosphere, such as methane and ammonia. These interactions cause the gases to absorb and reflect light differently, creating the vibrant colors we see. For example, methane's ability to absorb red light causes the reddish hues we see during the summer solstice. Meanwhile, ammonia's ability to reflect blue and green light creates the greenish colors we see in the northern hemisphere during its summer. But it's not just the color of the planet that changes. The churning of the liquid hydrocarbons also creates waves and ripples on the surface of Saturn. These waves can be seen from Earth using powerful telescopes, and they provide scientists with valuable information about the planet's atmosphere and interior. By studying the waves, scientists can learn about the properties of Saturn's liquid hydrocarbons and how they interact with the atmosphere. They can also use the waves to probe the interior of the planet and learn about its structure and composition. Overall, the churning of liquid hydrocarbons beneath the clouds of Saturn is a fascinating and dynamic process that plays a major role in the planet's appearance and behavior. The atmosphere of Saturn is mostly made of hydrogen and helium, but there are also trace amounts of other gases such as methane, ammonia, and hydrogen sulfide. These gases play a significant role in the planet's seasonal changes. The changing composition of the atmosphere and the amount of sunlight available creates a variety of colors that we see on Saturn's surface. For example, methane absorbs red and infrared light and reflects blue and green, giving the planet a greenish hue. Meanwhile, ammonia reflects blue and green light